Okay.
Trying to Zoom lady is informing you that I'm recording the meeting.
Yep. Page 18 is number 6, number 30, May, June 16, paper 11, question 13 and 14.
Okay. You can see the share screen, right?
Yeah.
All right. Okay, so let's see what you have done.
I still don't know how they got P over, is that pressure? Yeah, pressure over G over GX.
Okay, so pressure is not F times A, right?
F over A. Oh, goodness.
Yay, now you know. Good job. Okay, fix it now. It's okay.
Oh,
Brain
goodness.
sometimes just, yeah.
Oh, that really spoiled the mood. I was trying so hard. I was like, how? Where does it make sense? A and X has to go together to get V.
Yeah. Sometimes your brain just like plays a trick on you. So it's okay to walk away from the question one, then come back and then you're like, start again.
Oh God. Okay, yep. P is F over A.
So the A will be down here, right? The A will be down here. I'm not sure what you're considering here, but
Yeah, if the A is down there, then now it makes sense.
so
Because the G will cancel out and then the A will times with the X, which makes it the volume, then mass over volume will give the density.
So, okay, yeah?
Yep.
All right. How is 14, the trailer question? Okay, no.
No, I tried. I don't really understand what happened.
Okay.
Like I looked at it and I wanted to like attempt it. Then I was like, I'm taking too much of time. Let's just put an answer.
Okay, we need to draw all the forces though.
On X lah, basically.
Because they say by the cap on the trailer. So maybe I draw this one first. Upward force exerted on X by the cap on the trailer.
Okay.
So if you look at this hinge, right, like I zoom in on this picture, you see this, right? Then it looks like this, right?
Yep.
Okay, so question. This upward force exerted at X, so this is X already, by the cap on the trailer. So there will be a force like this now, right?
Yeah.
Force, maybe in this direction. Yes? Someone draw a force here. I mean, let's say it's F. I want to find F.
Okay.
Any other forces?
Downward force.
What's the name of the downward force? Why do you think there's a downward force?
I mean, if the cap one exert upward force, it has to push X on the other side.
Yep. So then this force is on the trailer. Right? So that means the other downward force is actually on the cap, which is this part here.
Yeah. The cap pushes X downwards on the other side.
Yeah, but I don't care about the cap.
Okay.
Does that make sense?
Yeah, that makes sense.
Because I mean, there's one. I mean, there is.
Okay.
Understand?
Yep.
Right.
Then there's weight of the trailer.
Okay. They very helpfully labeled for us, so we'll say thank you. It's like 30 kilonewton. Okay, what else?
Weight, upward force. That's it.
Okay. I don't know.
I mean, yeah, there's weight at X. There's upward force.
My trailer sort of stops here. I mean, I guess I can include this one lah, but this is the trailer, right? This whole let me color the trailer lah. What do you think? What are the other forces? We have a list, right? Maybe you can run through the list.
I think the contact force on the tires.
Ah, good
Upwards.
call, good call. Is it on both tires or only the back tire?
On the tires of the oh no.
Because this is the trailer.
Yeah.
And
It's the back tire only.
yeah, and this is the cab.
Mm-hmm.
You get it?
Yep.
Okay. I think they drew it in such a way where it hopefully looks obvious to people, but I don't know, man. Sometimes students, they don't look at the diagram. They just, I don't know. Maybe they need colors, color for you. Okay.
Goodness.
All right. So do you know what to do now?
Moments
Okay. So you take moments about which point?
about X.
Okay. Okay. I mean, but wouldn't that make F the top of F0 or the moment of F0?
Oh yeah.
Yeah. So we kind of like need to find F. So I really can't take X. Otherwise I can't find F. Which is sad.
Oh, that makes sense.
So which point should I take as the pivot or the reference point?
That means this.
Which point?
1, 2, 3 forces. You want to find that. That means we need to eliminate one of the forces. So I think the back part.
Very good. So we're gonna take this point, okay?
Yeah.
All right. So this 30 kilonewton is going to be this direction.
Mm-hmm.
This F is going to be this direction, right?
Yeah.
So 30 kilonewton, or rather F times 20
20.
is equal to
30 times 10.
30K times 10. So F will be equal to
Or 15.
50. Yay!
Okay. Now I understand.
Where do you get stuck?
I didn't understand like whether what I must do or what am I supposed to look at. Like they asked for upward force exerted at X by the cap on the trailer. I think I got lost there because I was like at X, I was thinking of X as like the what? So I was like, I think I was confused, like why they didn't give the weight of the cap and
I don't
whatever.
care about the cap.
Yeah.
It's a bit like main character, you know.
Mhm.
You watch Spider-Man, you don't go like, why they didn't give the backstory of the of this random bystander B by the roadside? No one cares about bystander B by the roadside. Although maybe Spider-Man ran into him. Who cares about bystander B by the roadside? You get the point, right?
Yep.
Don't label all the forces on the main character first.
Okay.
And then after that, step 2, you choose your pivot wisely.
Because we don't know what's I mean, like we don't need to find the contact force or the normal force. So
maybe another question they'll ask you to find the contact force, but not today, not this one.
Okay, this
I can
makes
make
sense.
it really hard, you know. I can add a spring here.
A string?
Spring.
Oh, a spring.
The shock absorber, right?
Uh-huh.
So then that spring, the spring pushes the trailer up with this end, and then this spring here is going to push. It's going to be compressed, right?
Mm-hmm.
So this end is on the trailer, but the spring experiences a compressive force. So I can actually ask for N by asking you like, oh, the spring constant is, I don't know how many Newton per meter, find the compression of the spring.
Oh.
Totally possible.
Oh, now that will kill me.
I mean, can't you find N? N is 15, by the way.
And
This is 15.
N is 15 as well?
Because sum of upward force must be the sum of downward force.
Oh, yeah.
Yeah. Why would it kill you? What's the force for spring? F is equal to kx.
Mm-hmm.
So I just need to give you k. Then you can find the extension of the spring already.
Yeah.
So I can say state the or find the change in length or the compression of the spring.
Oh wow. Okay, this is some interesting stuff.
The link between all these chapters are together. That's why physics is hard, because I can randomly choose. It's a buffet.
Mm.
So you have to build up the analytical skill, not all the questions are like this. That time has passed. It's not like this anymore.
Mm. Okay. So that means when you said that n is 15 because F, oh yeah, upward force or
Yeah.
upward force must equals to downward force.
No other forces already.
Okay. Okay. Oh yeah. If it's not balanced, then the trailer will be going downwards.
Yeah, and also if you take pivot here, it's also balanced, right? Because same distance, 15, 15, left and right.
Mm-hmm. Yep.
If you pivot here, also balanced, right?
Yeah. Yeah.
Balance, equilibrium, everything is balanced as it should be.
Mm-hmm. Okay. Okay.
Okay, next one.
Next one is
The piston
the
question.
ON16. Yeah, the piston one. I have no idea how they got that.
Okay, so you use P is, what's the equation again? I don't see any equation. What do you use?
P equals to, oh no, don't tell me I use FA.
Possible. Try again.
Okay, let me just try again. Force 800. So I definitely use P equals to FA. Yeah. Yeah. If it's 800 over 8, it's not supposed to be 0.64. Oh goodness.
It's okay. Like equation.
Yeah. Yeah.
Mm.
800 over cm square negative 4. How can I do this and not realize where I went wrong?
You're human, right? Are you robot? Just checking.
No.
Okay, great. You're human. So sometimes we have blind spot lah. And the reason why you need help, or we all need help, is because you can't see the blind spot. And we hope to be able to grow to be able to notice them.
Yep.
I mean, if you are perfect, then we don't need to be here, right? I can take a nap. You can take a nap. Correct.
Okay, now I understand why it's 12,000. Because it'll be 1 mil times 12 10 to 4 negative 4. Yep. Say 12,000 plus 1,200.
Okay.
Yep.
Okay.
Oh, so they put that 530 knowing that some people will put P equals to FA, is it?
Yes. See, you are not alone.
Ah.
Now I circle here big for you. You're not alone. If I'm you as a student, I'll just highlight the whole thing. P is F over A, P is F over A. So if it's like 1 minute panic outside the exam hall, I also can see this.
Yeah, I think I was doing, when I was doing the paper 2 as well, I realized I keep writing P equals to FA and P equals to FA. And I was like, wait, there's something wrong. There's something going wrong somewhere.
It's okay, now we know.
But then when I was doing paper 2, like I've seen quite a few that wrote P equals to F over A. I see. There's careless mistakes like this. So annoying.
If you can catch them earlier, that would be great.
Mm-hmm.
So the problem is the thing is not really about not making careless mistake, but being able to detect them.
Yeah.
This one looks a lot like the trailer, right?
Oh yeah. What is the horizontal distance of the van's center of gravity?
This van does not look uniformly distributed, right?
No.
The center of gravity can't be in the middle, right? I mean, if it's the middle, then you just divide by 2 and then go home. No, there's no answer, I don't think. The van is 2 meters long. It's a very short van though.
2 meters long. Yeah, it's quite short.
Very short leh.
2.
Remember your cohort got this really tall guy?
Who?
Oh yeah, but he did SPM. The IG classes, there's this really, really tall student. He's almost 2 meter already.
Huh? Oh. I know who you're talking about, miss.
Chinese guy, but I don't remember his name. Super, super tall.
Yeah, I don't really talk to him, but I know who you're talking about.
If
There's
you are
this one
tall,
guy.
everyone will notice you. So he's like 1.9 something already. So I know.
He's 1.9.
Can tell.
Oh.
Okay, anyway, let's continue. Because when I stand beside him, I feel like a dwarf and I am tall. So
Yeah,
seldom I talk to someone, I need to do like this. Most of the time I do like this or like this. So, but, oh,
yeah, he's quite tall.
Come on, he's Miss Ellie's student. So we you know how Miss Ellie and I we parallel our class.
Yeah.
So he knows me. And he's like, Miss Lee, oh, you're very tall. Miss Lee, you're also very tall. I didn't expect Miss Ellie to be this short. I'm like, ha 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 ha. Because Miss Ellie and I like same size in the video. Then when we show up in person, right, they're like, Miss Ellie stand behind Miss Lee, cannot see Miss Ellie leh. Thanks guys. Very nice.
Oh goodness.
Yeah, so we don't know where the center of gravity is, but it's a very tiny. Maybe it's a mini van, I don't know. Okay lah, maybe somewhere here. Right?
Yeah.
Center of gravity is where the weight is acting on. Okay, what to do? I think all the forces are labeled, right?
Except for the weight. But they didn't give the weight, so we don't really need to go.
Are you sure they didn't give the weight indirectly? Like, what are the conditions for equilibrium?
Oh, wait. So the weight is 25,000?
Yes, very good. See, you're learning from the previous example.
Okay.
Okay, try to find the distance then.
Actually, I remember doing something, just that I didn't write it down because I was like, I don't know. I think I was lost somewhere. I just went lost out of nowhere. But then I know, like, because the front is more heavy, the moments at the front would be like higher if the distance between the 16,000 and the 9,000 were to be the same. So I pushed it in front.
Closer to 16,000.
Yeah, closer to the 16,000, and I made my decision there. And I was like, okay, like this would be the, how to say, as long as I'm not picking more than 1.36, then I'm fine. Or no, I was like, not more than, wait, what did I do? 1.5 divided by 2. 2.5 divided by 2. Yeah,
so
it must
basically
be lesser than 1.25, basically.
But you got 3 options that's lesser than 1.25.
Yeah, I was like,
strategy doesn't really
be
work.
1.14, right? It's too close to 1.25. Let's just go for B.
You cannot tembak like that.
Yeah.
Don't tembak.
Yep. So here we have the weight, don't know where. So we need the left equals to, oh no.
Let's choose a pivot.
Pivot, where can we choose the pivot?
Anywhere. You have all the forces. There's no unknown, so it shouldn't matter.
So I can choose at the 16K, it doesn't really matter?
Yeah.
Oh. Okay.
Would you like to choose 16K?
If I choose at the 16K, then the part where they say 0.6 meter and then 0.4 meter, is that like Is that useful?
They say front of the van, right?
Mm.
So where's the front of the van? The orange X or the orange X or the red X?
Oh, that's the red X.
Yeah, so they just give you
Oh,
they give you all the length. Use it however you want.
okay. So basically the 0.6 and 0.4 is just to okay, understood.
But the wheel is here. I mean, it'd be very weird if the wheel is here, right?
Yeah.
Can you imagine going through bumps with your wheel so forward to drive a car? It would be a nightmare. You keep scraping the bump.
and down.
Just cannot. Bad car design. Please don't buy. Yeah.
Okay. So from that, 9K must equal to 25K. 9K is 1.5. Oh, okay. 9 times 1.5 equals to 25K times we don't know what. That means 9 times 1.5 divided 25. 0.54
So
plus by
0.54
6.
plus 0.6.
Yeah, plus by 0.6 because I took at 16K. You get 1.14.
Yay.
Now I know how to do this question. Yeah. Okay.
That,
Oh yeah, this last one at the back.
I think they are giving you this 0.4 so you can just minus rather than looking for this, which you also don't know. Right?
Pardon me?
I think they gave you this 0.4 m at the back so that you can minus 2.5 minus 0.4.
Oh, why?
Because I want to find x, right? We took this point as a pivot, right?
Okay.
So it should be 2.5. This distance here. This distance is isn't this the distance for isn't this 2.5? I guess you can use 1.5 right? Or 2.5 minus 0.4 minus 0.6.
Oh, I see.
Yeah, if they didn't give you the distance.
Oh, okay.
Yeah, okay. So you get 1.5. Okay. So 25000.
Yeah.
Okay. So always remember there is still upward force equal downward force. Don't forget this.
I'll just write that down.
Also left is equal to right, but in this case, there are no left and right forces.
Yep. Force upward equals to force downwards. Yeah. I need to remember that as well. Keep that drilled in the head. Okay. The last one is the star thingy. I think like I ruled out B and C because I know for it to be like how to say how do I say this? It's like in the diagram that I draw X and Y have two different angles and Y looks to be more steeper than X. So based on that, what I did was I was like, if Y needs to be more steeper, or I mean like the rope or the string at Y needs to be more steeper, Y need the force 2 must be higher than force 1. So I eliminated 2 options and I was like 50-50. I was like, okay, you know what? I don't know where to go from here.
So you did, the thing is you don't know the angle, right? You put X and Y
Yeah, I tried something. I don't know.
Okay.
I was
So
trying
there
to
is
find-
also the triangle of forces, right?
Okay.
You know how to draw the triangle needed for between these three arrows?
Triangle of forces. Which one is going down? One is going this way. The one is going this way. Oh. Okay, yeah.
So 10
A bit.
Newton, this one go
Yeah.
like this. This is Y, right?
Yeah.
No, not
And
Y,
then
sorry.
X will be
F2,
going
F2, F2, right?
F2, yeah.
Yeah, and then F1 is like this, right?
Mm-hmm.
Is this angle 90?
Yeah.
Pythagoras, which is the Pythagoras triplet?
Oh. 6, 8, 10.
Very good. From 2 maths pass. So you started correctly. You understood that the angle relationship has to apply, right? One has to be
Yeah.
smaller than the other. So you know that F1 must be less than F2, the first criterion.
Mm-hmm.
The second
That I knew.
criterion is the triangle. Triangle it is 10. 6, 8, 10.
Yeah, yeah. 6, 8, 10.
Yeah.
3, 4, 5.
The 4, 6 doesn't. Also, you can also know that, you see, 4 plus 6 is already 10. And the only way for 4 plus 6 to be 10 is for F1. It's for, F1 to be 4. And then F2 is 6 to balance out the 10 Newton.
Yeah.
Yeah. So this one really you can, in fact, the first thing I will rule out is these two.
I see.
Does that make sense?
Okay.
Because
yeah, in this case, that makes a lot of
because
sense.
you need these two to counter 10,
Mm-hmm.
right? Or maybe, draw like that. That's why I think both skills are important. Yeah.
No, I'm just trying to think like, when do I use this triangle of forces?
Whenever there is equilibrium.
Oh, okay.
So your equilibrium, right? What are the conditions? Do you remember?
Equilibrium as in like
Condition.
resultant force equals to 0.
Then?
Resultant moment equals 0.
So I'm pretty sure you know how this looks like in the equation format, right?
Yeah.
Up force is equal to down force.
Mm-hmm.
Sum of fx is 0. I don't know. Okay, then
Yeah.
there's diagram. Diagram is the cyclic triangle. Now this one.
Yeah, the triangle that doesn't meet.
It meets.
I mean like it's not like a vector lah.
It's like going nowhere lah. That's equilibrium. Yeah. You go nowhere, you are there.
Yes.
Everything is just there. It's a cycle.
Mm-hmm.
Okay. So this torque again got equation, which we have done quite a few questions, right?
Yeah.
Okay, so I'm not going to write the equation already lah. So then there's also diagram. Do you know how the diagram for zero torque look like?
No idea.
Okay, let's try a question then.
Pardon me?
Let's try a question.
Oh, let's try a question. Okay.
Okay, let's look at page 15.
15.
Page 15. You see the ball on the inclined plane?
Yeah, question 13.
Yes. Have you done that question?
Yes.
Okay. How do you do that question?
How did I do the question? Similar way.
Explain your thought process. Last time someone observed my teaching and then I say, okay, so how do you come up with the answer? Then the person that observed me say, it's too aggressive. You should say, explain your thought process. I'm like, it's the same question. Okay, never mind. I come from Kepong lah, so I speak like gangster. Same, right? It's the same to me. It sounds the same to me. Okay, explain your working. Explain your thoughts.
Oh, is it the one where they? Oh, now I know which one.
Which one?
It's the same one that we did the bar.
Yes. Okay, what did we do?
The one where we need to go and meet in a certain, like all the forces meet in a certain point.
Yes, yes, very good. All forces extrapolated
Okay, okay.
forces meet at a point.
So means there's few questions I think I've came by the one where they asked like what is equilibrium, and I was only able to write that resultant force equals 0 because that's the only thing I knew.
Don't forget the second one.
The second one is always fixed as resultant torque or resultant moment equals 0.
Ah,
Oh, okay, okay, okay.
okay,
Yeah, understood, understood.
beautiful. Okay, we carry on. Next one.
Next one is paper 2.
Mhm.
I did the one that you asked me to do, miss, the October 2022 and FM 21, 22.
How was it?
Let me just have a look. The FM 21, 22, I think there's few of it. Like I've seen the question like 2 times in the same book. Yeah, it's 2 times here.
Cambridge will repeat similar stuff. One. For objective, they will repeat word for word, identical. For paper 2, sometimes they will change stuff up a bit.
No, I think page 18 and page 21 is both the same. They just printed twice.
Oh, okay. 18 and 21.
Yeah.
Okay, no? Printed twice. Human error.
Mm-hmm.
How is page 14?
Page 14.
Because you took photo of page 14.
Yeah, we can do that as well.
Okay, so what is your picture is cannot be used, so I will crop myself.
Oh, I didn't take photo properly.
You take photo of half of one page and half of the other page. Yeah.
Really?
You go and see the photo and see. It's not trained.
Oh no, it's got what happened?
Hit okay, don't worry.
Oh yeah, I took half of one page and half of
Half
the
the other page. Very good, very good. I
yeah,
cannot read the question. Never mind, never mind. Then I paste all already while I complain
Okay.
about it. See, done. So online learning is actually okay one because I have 2 screens rather than struggling with an iPad. You see.
Mm-hmm.
Yep. Okay, definition is fine. This one is fine. It's 31 Newton.
Yeah.
Explain why the force on sine B doesn't have a moment about pivot A.
I thought force at B is parallel to A. I didn't know
I mean,
whether
okay, now you see, force at B, can we crop this answer? Force at B is parallel to A. Okay. Force is represented as a line, correct?
mm-hmm.
A is a point. How can a line be parallel to a point?
Oh, okay. So this is definitely wrong.
Does that make sense?
Yeah.
Okay. So you can say the line of force passes point A. So that's why it has 0 perpendicular distance.
Okay.
Passes point A.
I was thinking whether should I write like force at B has 0 perpendicular distance to A.
Yep.
But then I was like, it's the same as parallel and 0 perpendicular distance.
No, because point A can, I mean, if your parallel meaning is like this one got top or not? Second
Got.
case got top. Yeah. Parallel also. I'm sure you no idea what you mean by parallel. Because there's a point and there's a line. Point got no direction. So how to parallel? What to parallel?
Yep.
Is the line like this? Is the line like this? Is the line like this? Yeah.
Understood.
All right. Part 2. Taking moments about point A. Okay, this one a bit sneaky. Show the weight of the sun. You didn't do anything?
I think I was like, I did A, B, B1, B2.
Yeah, part 3.
Yeah.
How is part
Then
3?
I looked at part 3 and I was like, wait, okay, hold up. jump to part 4. Then something happened. I just skipped the question. I did something else. So I just wrote down the answer at the end. But I think I know what is happening.
Don't look at the answer. Do first. You copy the answer, you understand the answer, doesn't mean you can do, you know.
Yeah.
It's a bit like,
Understood.
oh, I watched my teacher do physics, I understand. Can you do? Don't know. Okay,
Mhm.
so what to do here?
Because they say at point A, by taking the moments at point A,
Hmm.
there's only, I think we only need to look at the upwards and downwards.
You mean W force here lah.
Hmm.
Then what other force need to consider?
The contact force. That means because one is at A, at point A, the frame is like this. So we need upwards to counter downwards.
So you are proposing that we use this. Upward force is downward force.
No. I mean, I'm just, how to say,
Okay.
like to counter the weight,
Hmm.
the moments created by the weight, we need a force upwards.
Sure.
Right?
I mean, it's not wrong, but it's not the whole picture. Like, what's going on here?
No, because like, how to say, and there's also the force on the wall. By
Yeah.
the
So
wall on
maybe step by step first, you're trying to jump to step 3. What is step 1?
draw the forces.
You can only jump to step 3 if you don't need to have tuition with me.
Okay.
Because then I won't nag you. Two forces cannot. You miss out a force, then you think only got these 2 forces and everything wrong. GG.
Mm-hmm.
Okay, so what are the forces? I draw W for you already. What else?
There's W, there's 54 sine 35
Direction of 54 sine 35.
upwards.
Is that the only 54 sine 35?
No, there's also the what?
Is this the only force?
Pardon me?
Don't they come in pairs?
No, there's also the 54 cos 35.
Okay. I draw.
Then there's also the force by the wall on the sine at B.
All right. Normal.
Mm-hmm. That's it, I guess. And at A as well, but because we're using A as pivot.
Okay. Then how to start?
So the moments about A means
Also, there's the friction now, but again, friction doesn't matter. So it passes through A, no perpendicular distance. This normal force, no perpendicular distance. I don't even really care where the friction is now, either here or up. I also don't know. So all this red one got no perpendicular distance. Okay. Okay. They say take moment about A.
Yeah.
Okay. So moment about A. How? Maybe we can start with one of the forces.
Moment about A would be 54 sine 35.
Mm-hmm.
That would mean it's moving anti-clockwise.
Okay.
And then plus with
Wait, 54 sine 35 multiply.
Multiply by 0.68.
Okay, very good.
And then 54 cos 35.
Anti-clockwise also.
Yeah,
Okay, good.
that is times 0.68 as well.
Okay.
Then because we know the contact force at B is parallel to A, or sorry, zero perpendicular distance to A, then we don't really need to look at it.
You mean this one?
Yeah, the normal
Zero
force.
perpendicular distance?
Huh?
The force is here, right?
Uh-huh.
The point is here.
Mm-hmm.
Isn't there a perpendicular distance? I'll draw here. The point is here. The force is here. A perpendicular distance. If it helps you, I add the bar for you. Now the bar. Perpendicular distance.
Oh, there is.
There is.
Wait. You know why the force on sine B does not have a moment about 0.8?
Does it have a moment about point?
It does not, based on the answer in 2, because it does not have oh, no, is it because that A at point A there's also a force?
With us, here.
Only in the vertical. Oh, force exerted on sine B is in the vertical direction.
So is there normal here?
No, there's no normal.
Yep.
Ah, okay.
Because here is only vertical. Read the question. That's why you must do a head count of listing and drawing the forces, because the property of the force may change depending on the question.
Okay, okay.
You don't do this. Look, even I do this. And
Yeah.
your diagram is so clean.
Yep. Yep.
Clean diagram is it's like, you know, your maths exercise book, very like, it's like your exercise book is new. Must look like you cried on it. It's like the pages are like not flat anymore. Some broken, like you rub too hard and then got a hole there. This one got student got study this one.
Okay, okay.
If the drawing is so clean, the first thing I tell everyone is draw. If I have to draw, are you saying that you are smarter than me? Then we don't need to have a discussion. You continue on it. So clean. Hello? Draw.
Okay, okay.
Okay, so what is your clockwise moment?
Clockwise moment with the weight
So it's W multiplied by
0.34 because it's in the middle.
very good. Yay, so you can find W.
Mm-hmm.
So a common mistake that sometimes students make is that they think that the 54 cos 35 got no top. Because it's like parallel to the side. So this one have no top if it's about B.
Yeah.
Yeah,
But it's not at B, this is at A, so it does have a top.
Yeah, and then they cannot get 150 and then their brain is stuck.
Mm-hmm. No, I mean, even if we look at it, like if we hang a picture using like we put a paper and then we put a pin at one of the corners, it will rotate the other way around, downwards. So because of that, I was able to, I told myself that there is moment caused by this wire.
No, they were trying to be helpful here. Why the force does not have a moment about A? Because it passes through the point. There's no perpendicular distance. But if you look at this 54 cos 35, there is a perpendicular distance.
Yeah, yeah.
Right? Because this one, perpendicular distance is here.
Mm-hmm.
So when I was a student, I struggle because in Form 6, right, there are more forces, and then it's very hard for me to see the perpendicular distance. To the extent where when I was first starting, I would draw the reference point and I would draw the force.
No, I see.
Like I would draw this that I'm drawing for you because I couldn't visualize. I'm not a very visualizing person. For me, hardcore algebra, no problem. All this picture with angle, cannot visualize. So you must know your strength, and then you must know what to do to address your weaknesses. No one is perfect, okay?
Okay.
In fact, the perfect teacher will struggle teaching you. That's why I don't teach language. People are like, you come from Kampong, but you can speak with good English if I intentionally filter away the slangs. What did you do? Go away lah. So calculate the total. I can't talk to people like that.
The vertical force,
Mm.
yeah, it's just 150 minus 31.
Because you know why, right? Why am I? Why?
Vertical component of the tension.
This is 31.
Pardon me?
Is this 31?
Is that 31? I have no.
Where do you get 31? From where?
Yes, 54 sine 35 is 31.
Yeah, so that means in your working, I must see the 54 sine 35 equal to 31.
Yeah.
Either in part 3 or part 4, don't just suddenly 31. Wow, from where? From how?
Also, that means, do I get marks for this?
One mark will be deducted if I can't find out how you get 31. Do you dream of 31? Is 31 your favorite number? Is it
But then it was calculated in part 1.
You didn't show how. Oh, okay, fine. You calculate in part 1, then can.
Oh, okay.
So if let's say they didn't ask you to calculate in part 1, you have to show at some point in time you're working that is 31.
Yeah.
Okay. So what condition are we using?
In this, to find the total vertical force, the equilibrium.
Which condition? There are two.
Upwards minus downwards, I guess.
Yeah. So upward equal to downwards. So up we have 31 plus. They want the vertical force by the wall on the sign, right?
Yeah.
So I put FV lah for vertical.
And
downward force is W, which is 150.
Yeah.
Okay. That's why it's 31. All right, wonderful. Okay, what happened here? This one is very easy. I don't know what happened. You want change in GPE is mg change in height. Final kinetic energy is half mv square. They even tell you what's the final kinetic energy because they give you the speed. So m and m can cancel, right?
Oh yeah.
You don't need to know the mass. Who cares about the mass? Whenever there's a ratio of energy, the mass will go away.
Yeah.
I mean, especially if it's mechanical energy like GPE and KP. So how far has the nut dropped?
4.8.
Very good. And we know the speed. The speed will be
9.2.
Yes. So press calculator, please. 1.1.
Yeah.
I don't know why this is 4 marks, I stared at it long time when I saw the question paper without the mark scheme. I'm like, how to give 4 marks?
Then where do they give the 4 marks?
You copy the mark scheme, you tell me. Okay, I'll tell you where they give. This MGH is 1 mark. This half MV square is 1 mark. You substitute 1 mark. Your final answer 1 mark. I think, right, they miss out 2 marks and they're lazy to set another question part. They just inflate this mark. Bonus. Take it. Just take the bonus. I understand. As someone who set paper, sometimes you're lazy now. So you just whatever lah, formula can lah, anything like right equation, I give mark already. Okay, let's move on.
I see. Yeah. So this type of stuff will happen.
It happens to all of us. Just like you lah. I look at the question, I don't feel like doing it already. Whatever lah. Okay.
Yeah, fair.
But the problem here is they get to whatever because they are the game master and you are not. You are playing the game. Does that make sense? No, do you understand the difference? I get to whatever when I'm setting papers because I am setting paper.
It doesn't affect.
Correct. So last time when I complained about this with my teacher just looked at me and said, do you have the A or do I have the A? And I was like, okay, fine. Understand already. It's okay. I take it. It's fine. Everything is fine. Okay. What's wrong with this question?
I didn't understand. Couldn't define the principle of moments.
Oh, I had product.
I wrote that product of
principle. So clockwise must be equal to counterclockwise.
Yeah.
That's all.
Actually, what's the difference when they say define moments and state the principle of moments?
So moment is FD.
Yeah,
Principle of moment is clockwise is equal to counterclockwise if an object is in equilibrium.
I see.
Ah,
So they ask for, if they say define, I'm supposed to write product of course,
times perpendicular distance.
the distance from
Yeah.
a point, and then if they ask for principle of moments, I'm supposed to write clockwise
Mm.
equals to anti-clockwise. Okay.
You should, I mean, if you want to, you can write both lah.
Yeah, sure. That works as well. I'll do that next time, I guess, when I practice.
Okay, let's see what's next.
Anything else that I did? Yeah. Oh, did I take photo of this?
Oh,
Page 18.
yes, you did.
Oh yeah, I did.
Okay, let me see. The FM21, right?
Yeah, FM21.
Okay, you drink too much coffee. So
Huh?
shaky. The picture is, I can show you lah. What is this? What happened?
Oh, my hand shakes since I have like very shaky hands. Wait.
Never mind. It's okay. I mark a lot of paper already. Let's take a breath. Let me show you
See,
something.
this one okay or not, bitch? My hand's very shaky.
I mean, I guess it's fine.
Yeah,
Because-
it's still bad. I'm not cut out to become a
No, because
photographer.
I had a student give me this before. So I don't know whether you remember your semester exam was MCQ.
Uh-huh.
And then I told them to draw a table. This is his table. You can't see it, I'll zoom in for you.
That's a table.
Yes, this is a table. Come. Nah. This is a table. I tell you, 12, 13, 14, 15, 16, 17, 18, 20 is here. No, 19, 20. Where is 20, 21? Then 22 up here, you know. Then 23. Why is 22 here? Why? 23, 24, 25, 26, 27. My goodness. I send the student this meme. I'm like, hello? Which part of table you don't understand? And then he was like, miss,
Did you post it in Instagram?
yes. I'm like, you don't want me to meme you, don't give me materials. I will meme the heck out of you. I'll share it with everyone. To Kingdom Come, your juniors will hear the meme. You graduate, you become some top engineer in some top oil firm. I don't care. I'm going to share. What is this? Okay, not all students can roast, but this one can. What?
Means I've sent another one.
Okay, good. Not shaky hands. Yeah, then there's another one that I didn't post on Instagram where the student didn't rotate the paper.
Huh? Oh, you just send it to you upside down?
No, 90 degree.
Oh, was it like online exam?
Yep. And then I
Oh,
just
then-
send I just screenshot that and send a meme of, you know, the person's head just tilted 90 degree. I crop my head and I turn it 90 degree and stick to my torso and send it to him. It's like, miss, you want me to take again? No, take better next time. Actually, what I can do is I can download, I can crop it and I can flip it lah. But extra work, why you give me extra work? Hello? I don't have enough work, is it? So I don't know. Gonna roast. I roast once, then after that remember already. It's like,
I think the part where I messed up was I forgot the equation for elastic potential energy.
Okay, so I want to talk a little bit about this equation.
Okay.
This equation can only be used if F is constant.
Oh, okay.
Because the actual definition for work done or energy is integration F ds. So we are actually looking at the area under the FS graph. So most of the time when you drag a block like that, the classic picture, this F is not going to change, right?
Yeah.
Doesn't change. So then your FS graph be looking like this. Then of course the area here is F times S lah, right? But this one looks like that. Okay.
Yeah, that's right. I told myself like to look at the graph and how to say, if like I don't know how to do, go back to the basic units and then figure out a way from there.
Basic units. No
Like
lah.
for energy would be like kg.
The basic units will not introduce half to you because half has no unit.
I mean, like in this case, like how to say, what I really meant by that was like energy is force times distance. So it'll be like kg m square s negative 2.
Yeah, but how does that give you the half?
Yeah, so that means I know that it's like f times x. So
then you F times x here, what?
if I f, yeah, but if it's like if I did this based on the graph, if I were to do f times x, I would find the area under the area, like how to say, based on the graph knowledge of like the SVA, area would be like what if I find the area, it will give me something, right? So I don't know. I was just thinking like we just work from there. If I forget, I'll just work from there. That's why I wrote like I shaded it. I wrote area under the graph is energy.
Yeah, I think it would be safer if you start with the definition.
Oh, okay.
Because the unit will never give you the half. What if I didn't draw you the graph?
Oh yeah, then I'll be in trouble.
Yeah,
I
may not need to give you a graph. I may just say, oh, the string is extended by 2 cm. What's the electric PE stored in the spring? Good game.
Yeah. Okay.
Does that make sense?
Yeah, understood.
Also, if it helps your brain, you may actually, I mean, I can do this, but it doesn't. I'll show you, I'll give you an example. Today, my student sent me this because I was curious. You did chemistry, right?
Yeah, I did.
Okay, let me give you some PTSD flashback.
Holy.
Alkene, hello, alkene, carboxylic acid. So my student go ask me, Miss, how you remember all of this? Then I said, do you want the honest truth? Every 2-3 days, I pull out a piece of paper, I write the whole thing out from zero. In fact, I draw all these arrows and then I photostat all empty arrows, and then every time I just fill everything in and just start everything again. It's memory work. So for me, I do repetition.
I
don't know what your strategy is, but to memorize equation, for some physics students, they have a list. I prefer to draw a mind map. I'm a very, if this then that kind of thing, or a list, so up to you lah. So for example, you can, if you look at this energy, this, I tend to like to use boxes. So for example, if let's say you want to think about you can do this for every single chapter one, work, energy, power. So it starts off with work done is F times S. So I don't do this because different people, different brain. So there is this that is parallel to this. I don't know which one works for you. Don't copy my brain. My brain is not your brain.
Yeah.
There's area under graph. You go and continue lah. Then there's GPE, there's KE, there's power. You can draw like that. Or you can just list down, number 1, number 2, number 3, like the notes that I give you.
Yeah.
But you have to find a way so that it becomes less, so that you can see everything in one glance. Or you can look like this. Like certain people, they prefer this. So the condition is F parallel to S, F constant. And if F is not constant, W is area under Fs.
Okay.
Something like this lah. So you can quickly look at it in like 2 minutes. So it will, because you are trying to carry 23 chapters in your brain one go.
Yeah.
You need to help your brain by, oh, we did kinematics. I've forgotten everything about kinematics. Don't panic. Okay, take down a list. What is the must know about kinematics? Write everything down.
The 4 equations.
Yeah. Do you know how many of that organic chemistry mapping I did? I have 32 classmates in my class, Form 6. I have another 34 in the next door class.
Okay.
Out of them, because out of these 60 something people, I think at least 40 to 50 of them study from the mind map that I make, because I finished already, I double check, I make correction, and then I throw away. So I was throwing it away until my friend like give me. So I gave them. So we've been passing it around to the whole class. So I think I at least wrote 30 or 40 copies to practice.
Jeez.
So it's like a warm-up thing, that your brain helps you organize the information. It's a little bit like for example, this one. Do you think about this like this? I'm thinking about it like a tree diagram. So I think a lot like a flow chart, a tree diagram.
I see.
So again, if I am going to draw this to suit my brain, I will just draw the picture like there, and I ask myself, is F constant? So F is not constant. So if F not constant, what are examples that I tend to see when F is not constant? Oh, spring.
Yeah, that's the first.
Go to spring now. Yeah, so as you accumulate, you have to summarize your thinking. If not, then you keep missing out stuff. And then so whenever you recall the equation or the concept or the law, and you remember, I was that bugger who wrote pressure is force times area.
Yep.
It's okay. You move on, okay, won't happen again.
Yeah.
You gotta help yourself, because your brain cannot keep remembering stuff when you will forget with time. Okay, so this one.
Which one, Miss?
The other one, page 20.
Oh. Page 20.
What happened to page 20?
Yes. The unit, I made a careless mistake. I saw cm negative
very good.
velocity is centimeter per second.
Yeah,
It's supposed to be meter per second.
It's okay. It happens to the best of us. Just remember to double check in the actual exam.
Yep.
Give yourself time to go through. Viscous force increases with depth.
That is what the answer wrote. I was thinking like because viscous force viscous force increases with depth. Then pressure? Is that pressure?
Nope. Pressure is linked to upthrust.
Yeah.
And upthrust is constant. So if you think about your ball and it's falling, what will affect your viscous drag?
The speed.
So as I fall, will my speed increase or decrease?
Decrease.
So this is where you should start your explanation. As the ball accelerates, or the cylinder, what is it, a cylinder? Or as the cylinder accelerates.
Yeah.
The viscous drag increase. So this point is memang wrong one.
Okay.
The pressure is actually the same. The pressure difference is the same.
Pressure difference between the top and the bottom is the same. But then the pressure will be. Oh, okay. Yeah.
I mean, maybe it was 100 and 200 lah. Then as it falls lower, it's going to be, I don't know, 250 to 350 though. I mean, the difference is still going to be 100.
Oh, yeah, because the height is still the same.
So the only thing we care about is the pressure difference. That's like not relevant. So the viscous drag increase. Because of this, net force decrease, correct?
Yeah.
So then acceleration decrease. Okay. So if you want to use the depth, then as the cylinder accelerates with more depth, the viscous drag will increase.
Okay.
Okay. Any more questions?
I'm still. Oh no, yeah. That means this one I'm done at the back.
Hmm.
There was few from the. This one.
Hmm.
Where do I need?
Okay,
Yeah,
another.
I did circular motion.
Okay. You mean
Uh,
gravitation, right?
yeah. Gravitation.
Hmm.
This one I already asked. I'm supposed to do this. So basically, what I did was I was like, you mentioned to me that time, like, there are certain parts of gravitation which, like I have not been practicing and like lack the knowledge in. So I went back to the videos and then I saw like the 13.1 to 13.3, whatever, A to C.
Hmm.
I listed it out at the back here.
Okay.
Like if you can see, cannot see, I'm not really sure. So I
Okay.
listed it out at the back here, and then
Hmm.
I went through the questions, like I just flipped through and then I labeled it, folded it, and then did it
Okay.
for that day. So if I'm not mistaken, there were a few, like the last question that you said, the one with the potential, page 41.
Okay.
Yeah, that was fine. Like everything was all right. I think so far, like whichever that I did, I've asked already, I guess.
Okay.
Yeah, this is all okay.
So is there anything you would like to clarify from there?
Oh no, this one I think all I asked already. Yeah, all of this I asked already. And I'm very
Okay.
close to finishing the.
So what videos are you watching now?
Now I'm watching Ideal Gas.
Hmm. Are those chapter easier because you did do chemistry? Right?
Yeah.
So
Ideal Gas is more
chemistry
just
chapter.
calculation based. So a bit of theory, but mostly like formula. Like there's a lot of formulas in Ideal Gas, right?
Um,
The pressure law, gas law, Charles law, Boyle's law, whatever law.
the pressure child, the one is not really in the syllabus.
Oh, no more.
No, as in like it's not being asked. It's not in the it was never in the syllabus.
Oh, then why?
So we tend to mention it to make the link with past years,
Oh, I
with
see.
your IG or your SPM.
I see.
But it's not in your syllabus. So don't think that that is the focus of the chapter.
Oh no, I mean that's not the main focus, but it's more like there's also few constants, gas constant, RK. Oh, yeah, I need to go watch it and then get it done.
No, I don't know. You need to do something like this. I don't know lah. Show me what is your thought process like. Is it listed? Is it something like if you don't have time, you can just jump to the review series here.
Pardon me?
So thermal physics.
Uh-huh.
That
There's
okay
two.
on the channel, right? I do
Yeah.
a speed run through the entire syllabus one. It's just
Oh.
that there will be not enough detail. So it's more for revision purposes. So if
Yeah.
let's say you already watched the video and you feel that you understand, then you can go straight to
To those videos and watch
the
it from there, so
review.
I don't really waste time watching it back all over again.
Yes, I don't know. I'm trying to help you save time because I actually don't know. What is an acceptable grade outcome for you?
I'm trying for A now.
A is quite hard because of your pace.
Yeah. I understand that.
You understand that, right? So if
Mhm.
you want an A and you want an A that you can live with, then here are places that you can speed run.
Okay.
So it's the whole chapter in this. And then I timestamp everything already.
Yeah.
It's all me one lah. Okay. So what is this? Oh, this one is gravitation. No, I don't care about further mechanics. Okay, this I do guess. So you can see these are all the examples.
Mm-hmm.
So it's just crash course.
Yep.
Yeah, and yeah, that's it. So the entire crash course is here one. The whole everything in the syllabus is here. It's just that some of it is not in your syllabus. So communication you don't read, it's not in syllabus anymore. So skip the communication, skip the operational amplifiers.
Oh, it's not there anymore.
No.
Oh goodness Lord.
Why?
I struggled with that a lot last year.
Okay, I'll throw away. Anyway, Miss Ellie and I will record this lah. But I did a live session to teach this for the new syllabus if anyone wants it before the Fed March series. So it's really based on how well you can help your brain learn while still not forgetting what you have. Does that make sense?
Yeah.
Your current pacing is way too slow.
Okay.
Because we've been doing gravitation for a month.
Yeah. Yeah.
How?
Can I'll pick up the pace, I guess.
But I also don't want you to pick up the pace and not learn anything lah. So you have to find the right pace.
The right balance. Yeah.
But now it's still too slow.
Okay.
Okay, so would you like to see me twice next week?
Actually, I did work energy power.
Okay.
I was practicing some at the moment. There was the few stuff that I actually wanted to ask were page 26.
Year and variant, please.
Oh, FM20 P22. Question 3.
Six. FM20.
Yeah.
Page 26.
Yeah.
Not 27.
Okay.
I guess you're printing the old one. FM20, which one?
P22.
Oh, paper 2, not paper 1.
Oh, paper 2. Yeah, paper 2. Paper 2.
Didn't say. How I know?
Sorry, miss.
Okay, which question? Which part?
Question 3. Is it the skier?
Yes. Can take picture.
Oh, can.
Throw inside. I need to see your working. If not, then it's just you watching Miss Lee do question, which is just like the videos. No point.
Please, hands don't shake.
I'll work with what you give me.
I think all the calculation, everything here is all right. Only the last part.
Last part. Isn't this the area under the graph?
I didn't know the strain energy is equal to elastic potential energy.
Okay. Do you know now?
Now I know.
Okay.
I was like, if I knew that, I was like, strain energy is actually elastic potential energy. Because they say calculate the change in strain energy. I was like, what is strain? And it goes like, it repeats like quite a few times.
Yep. Because it's the same thing. You stretch a wire, you stretch a spring, you store energy in it.
Oh, so that's
it's like stretching a rubber band. It's elastic potential energy, it's strain energy. It means the same thing.
Yep. Understood. I think page 27, the next page, out of all of it, I lost 1 mark in the definitions where they say the conditions to be equilibrium.
Okay.
And then page 28. Question C. I did this.
What do you draw? Straight line, curve?
Straight line.
Increase, decrease?
Oh no, constant.
Like this?
Yep.
Let me read the scenario first. Okay. Part 2, got answer or not?
Part
B,
two?
part 2.
B, part 2. Yeah, I got 2.7.
Okay, so can you tell me the energy conversion? What converts to what when the ball is dropped from the top of a building?
Potential converted to kinetic.
All of potential 100% convert to kinetic.
In this case, no, because there's energy loss.
Okay. Energy loss due to
Resistive force,
Mhm.
air resistance.
friction, right?
Yeah.
So what is the forces acting on the ball then?
Weight.
Yeah. So weight is mg, right?
Mm-hmm.
That is assigned by GPE.
Yeah.
What about friction?
Friction is upwards.
Friction will
Air
fight weight, right?
resistance.
So this is the
Yeah.
wasted one.
Mm-hmm.
This mg is the one that converts to ke because you can put mg equal to ma or mg minus f equal ma.
Mm-hmm.
So it's at the acceleration g.
Pardon me?
It's the acceleration g.
Uh-huh.
Is it g? I'm asking you.
Oh, at the start it's G.
Okay, then after that?
After that, as the friction increases, the resultant force will become zero.
Straight away becomes zero.
I mean, it will slowly decrease and it becomes zero. So that's why it's a slope. But then the marking scheme mentioned, like they said, not touching or some, I don't know what they said, but it was like not touching the x-axis or something like that. That's why I draw, if like you see my drawing, I draw.
Wait.
Oh, okay. Or was I just too sleepy and didn't realize that they didn't say anything? That could be the case.
So the question here is, did we reach terminal velocity?
Yeah,
How do you know?
because they say in the question, air resistance is significant so that the ball reaches constant terminal velocity before hitting the ground.
And what is T?
T is the hits the ground at time T.
So that means it will, the acceleration will be zero when? Before T, during T, after T?
Should be
before, during, after. Where is A zero?
If it's supposed to reach,
question.
it should be before.
Okay, yeah. So that's what they're saying. Decrease, hit here, and then continue to T.
Oh, okay. So that means I didn't
Line meets
understand.
the T axis for T less than T.
Okay. So my answer here is wrong.
And it's definitely not G all the way.
Yeah.
Thanks to friction.
So
you notice that they really like this terminal velocity thing. Occasionally they ask you to explain.
Yeah. There was one, I think, explanation.
Then the drag one, the viscous drag, increased with depth. It's like their favorite for people.
Yeah. Miss, the one with like Hooke's law and all that, do I learn? I don't learn in this chapter. I didn't learn in the previous chapter. Did I learn in the previous chapter, in chapter 4?
Young modulus, chapter 6.
Okay. That's why I didn't know.
But you are expected to know Hooke's law because you completed SPM.
Yeah. Yes, I completed SPM 3 years ago. Is it 3 years ago?
They don't care. They don't care. I took my driving license 10 years ago. I still need to know how to drive, right?
Yeah.
So that's the idea. I'm not sure whether it's fair or not for academic subjects.
It's okay. It is what it is.
Build a summary for yourself so that your brain can brain.
Yeah. I am planning to do so.
Great. I want to see it.
Okay. I'll get it done.
Okay. I'll check in on you.
This is okay, yeah.
Okay.
So this is okay. This graph is fine at the moment. This is looking good. Anything else? Yeah, the page after that, page 29. I didn't know Hooke's law.
Okay, that one is force is proportional. You see this graph, right? This is Hooke's law already. Force is proportional to extension.
Yeah.
Yeah.
Also, am I supposed to say force is force is I'm supposed to say force is
You can
proportional.
provide the context now. Force applied on a spring is proportional to its extension.
Oh, I see. Because the answer says that compression slash extension is proportional to the force provided limit of proportionality is not exceeded.
Yep.
I'm supposed to say the entire thing?
Yep.
Ah, okay.
The graph is a good hint to start you off.
Okay.
Right?
Okay.
The graph shows that X is proportional to F.
Yeah.
Yeah. So when it comes to proportionality, you imagine you do this experiment, right? Let's say you hang a spring. The thing that you change is your force. You put slotted mass, you change the force.
Okay.
Right? So if let's say you're doing an experiment and you hang a slotted mass here, let's say, I don't know, 100 grams. And then you hang 200 grams. This is your manipulated variable, right?
Yeah. The
Or
math
in
is
CIE, what do they call? They don't call manipulated, by the way.
This is
They don't use the word manipulated.
Oh yeah, they use. Oh no, independent, dependent.
Okay. So is the weight of the slotted mass independent or dependent?
That's the thing. I never really understood. What is it independent or dependent on?
Okay. Do you know the difference between manipulated?
Manipulated is something that is changed.
So which one do you change?
The weight is changed.
Wait. You change it yourself, right?
Yeah.
Use your hand, do it, right?
Yeah.
Independent person do your own change weight, right?
Yeah. Oh, okay.
What happens when you change the weight?
There'll be something observed.
The spring responds, right? So it's responding.
Yeah.
So this extension.
Okay.
But this response is dependent on what you do.
Oh, I see.
Does that make sense?
Okay.
Depends on what you do. So for example, I am independent person, I change the weight. I'm independent person, I go say hi to my friend. I go say hi, I go do it. Me, I independent. My friend responds, oh, linkage, nice to see you. Or run in opposite direction. It's a dependent variable.
Yeah.
They respond to your change. Can? So it's dependent to the change that you did just now. Okay, can.
Can.
I know like it's confusing because we did this for 5 years,
Yep.
So you need to give your brain time to change over, okay? So whenever you write proportionality, we tend to start with responding, then manipulated. How does X respond
to F?
How does the dependent respond to independent? So for example, if I want to know whether people like linkage or not, I just need linkage to independently go say hi to 5 people and I observe their observation. Now, if you say hi to 5 people come and, oh, long time no see, bro, what's up? Then I'm like, okay, like linkage, popular guy. Conclude.
Okay.
Does that make sense?
Yeah.
So that means I put maybe 5 different masses and I see how X respond to W. Or I put force, okay?
Okay.
Can? So that means when I write proportionality, I say X is proportional to force.
Okay.
Does that make sense?
Yeah.
So CIE is very picky about this. SPM don't care. You write proportional, they happy. You can say extension or change in length. Proportional. Force, right.
The POR supposed to be PRO.
Don't care, changing here.
Oh, okay. Can change like that. Oh, yeah.
Don't care, I also change here. Applied. Don't care, brain lazy to think. Because I memorize spelling by muscle memory one.
Oh, I see.
So when I write, it's correct spelling. When I type, SS whatever. Because I learned how to
Oh,
type later in life. Does that understand?
yep, understood,
Yeah, so I
understood.
use I work with my brain. I don't work against it.
Ah,
So they can correct. So whenever I type, I definitely can correct. The computer will correct for me, so I won't bother. But whenever I write, I don't have computer to correct, so I must write correctly.
yeah, that's true, that's true. That makes a lot of sense, right? Yeah.
Yeah, so sometimes it's okay to just get things to help you when the help is available and knowing what help is available and what is not.
Mm-hmm.
Okay,
Makes a
force
lot.
applied. Provided, because if you apply too much force, you're going to spoil the spring, right?
Mm-hmm.
So provided the limit of not exceeded. It's like terms and conditions. Terms and conditions apply.
Mm-hmm.
The buffet is 50 ringgit, provided you come exactly between the time of 8:02 p.m. to 8:06 p.m.
Is there such thing?
No.
Oh, okay.
I'm just saying. If you do like that, nobody come. Oh.
Yeah, that's for sure.
Okay, how about the rest of the question? Is it okay?
I think D, I had problem.
There's resistance, but so can you
Yeah,
tell me the conversion of energy from X to Y?
X to Y.
Mm.
X will be
Or maybe
kinetic.
okay. X is when it leaves the spring.
Yeah, that's kinetic.
Okay.
When it goes around the loop, on top of the loop, that will be potential. And then goes back down to Y will be kinetic.
So can I say that actually from X to Y is just kinetic to kinetic? I mean, sure, it went to GPE, but it's going to go back to kinetic, right?
Yeah, but
Like,
yeah, it's supposed to be that way.
okay, but is there friction?
Yeah.
The friction all the way?
Yeah, all the way.
The whole entire thing, right?
Yeah.
Okay, so here you lose energy. You lose how much?
0.23.
This one is 0.23 joule. Work done against friction. How to find work done against friction again?
W equals to Fs.
Is F constant?
Yes.
Okay. How do you find the distance traveled?
So here's where I made the mistake. I remember the displacement, that S equals to displacement. So
Nope.
I just put in 0.5, 0.55.
No, it's not displacement. This
But
one is the entire displacement, if you want to, where Fx on trolley.
okay.
So it's the whole thing. Friction. All
Because they said what W is, F is like the force, product of force and displacement in the direction of the force.
So friction is always parallel, right?
Yeah.
So if I'm here, friction is this direction. If I'm here, friction is in this direction.
I see.
If I'm here, friction is in this direction. Does that make sense?
Yep.
It's going like that.
Yeah.
So it's always the perpendicular distance because I mean it's always the parallel distance because the friction is tangential to the track.
Yeah. Okay.
Does that make sense?
Yep.
Tangent to track. So I need the whole length of the track.
I made two careless mistakes here.
Okay.
One is they said in the question, they said a resistive force due to friction and air resistance acts on the car so that the kinetic energy at Y is 0.23 less than its kinetic energy at X. So linkage being linkage, I saw 0.23, I minus 0.64, and then I wrote a new energy loss, which is 0.41, but it's supposed to be 0.23.
Yeah, and also related to the speed of the car at Y.
Yeah. And then the distance, of course, the displacement, of course, I made a mistake because I didn't take the circumference of the track.
2 pi r.
Is 2 pi 0.12. Yeah.
Okay.
Yeah. But yeah, so far that's the only things I have. Miss, could you have a look at this? I'm not sure whether my answer is correct. I'll just send a photo. Yeah, this part. I mean, whatever the marking scheme had wrote, I guess I have written. I'm not really sure. I don't know whether I have overmarked myself.
I need to see the whole question.
Oh, okay, wait. Now I'll do that.
What ball? Where ball? Who ball? Why ball?
I'll take the whole question. Can see the whole question. Please can see whole question.
It looks
Can
okay.
see whole question.
It looks okay. It is the traditional ball drop from height situation.
Really?
Yeah, it's fine.
Okay.
It's quite standard one, what, no?
It is quite standard, just that sometimes I feel like maybe I've overwrote it or what. I'm not really sure.
No. No.
Okay.
As far as the keywords, the mark scheme is for me to find keywords, not for you to copy in directly.
I see. Yeah. Yeah.
So then if you are marking yourself, it's for you to identify whether you explain the keywords with sufficient detail or not.
Okay.
Okay.
If you look in the other photo that I just recently sent, I made mistake for B2, which led to a mistake in B3. So B2, I made the mistake because it said that gravitational potential energy decreases by 60 as it falls from the balcony to the ground. So the change in GPE is 60, which is what I'm supposed to use.
Yep.
But
this is similar to the toy car problem situation, right?
Yeah. There was one part. And they said that the second part is the one where I don't understand. Why is it 60 minus 23?
Okay, draw me the energy conversion diagram again. Ball released from a balcony. Okay, line. What's the energy? What convert to what? Convert to.
Gravitational potential to kinetic.
Okay. Full conversion?
Yeah.
100%?
Oh, no. That's energy loss.
Okay. How much GPE do we have?
I'm not sure about the initial. I mean, I can count the initial because the height is there.
No, they gave already. The potential energy of the ball decreased by 60 as it falls from the balcony to the ground.
So is it 60?
You start from here, balcony. You end here, ground. These are, by the way, these are all change.
Yeah.
All of it is change. It's not absolute value. If you want GPE 0, you go infinity. Gravitational field 0.
Oh, okay.
So change in GPE is how much?
60.
Okay. And then the change in KE is how much?
23.
Hits the ground. Okay. So where did the rest go?
Loss.
Lost where? Why? Who?
Resistive force.
Friction. How much loss?
37.
Okay.
So that means when they say that the gravitational potential energy decreases by 60, that means it starts at 60 and decreases to 0?
Not necessarily. For all you know, this ball could be on top of a cliff.
Oh, I see.
Doesn't matter. Don't care. We don't care about absolute value. We only care about change.
Oh, okay. So just care about the change only lah.
It's all change, work done. The basic idea of this chapter is whenever you do work, you change energy.
Okay, okay, okay.
For example, this change from here to here is work done by gravity or weight or gravitational force. That's why it accelerates, right?
Yeah.
And then here, this conversion is work done by friction. So whenever there is a conversion of energy, there is always work done. And if you watch the lecture video, you will know that this half mv square origin story is Fs. This mg change in height origin story Fs. This P change in volume work done for gas origin story Fs.
Yep.
They are all descendants of the same ancestor. Same thing with half Fx. Origin story Fs.
Okay.
Okay. So this one dropped by 60, and then the Ke actually will fall slower. Okay, so the Ke will change. So this one is time. Actually, doesn't matter. It can be distance. It can be time. So let's say this is distance, like x. So this one. So this one.
So that means in this case, I don't need to know the initial GPE value.
You also don't. I mean, you know the initial Ke because it was stationary.
Yeah.
So this one sort of like increase quadratic because it's like falling faster and faster, right? So it increase, I don't know, somewhere here, but this increase is plus 23 joule. So there is still loss in friction. So energy loss to friction is this much.
I see.
So this one
The
from here
difference
to here
between
is
the black and the red.
So GPE decrease, these two energy increase. Heat,
Okay.
this is heat.
Yeah.
One down here is Ke. So what drive the conversion is these two forces, friction and gravity.
Okay. Because I was like, maybe I didn't really understand the question very well, but then I heard and it was like, okay, so the change in GPE is 60. That is what I know. And then KE is 23.
Increase in KE.
Yeah, that means that it's a change in KE. So
how do you know the initial is 0?
For KE, initial 0 because of ball falls vertically from rest.
Yep, very good.
GPE, we don't know. They didn't really tell us the height, so I don't know what it was in the start.
Doesn't matter.
So that means out of the change in GPE, that means for the part 3 is like out of the change in GPE, there's 23 of it went to KE. Basically.
23 of it converts to KE.
Okay,
37
okay,
converts to friction. How many times I draw this picture today, Leo?
Huh?
How many times I draw this picture? See?
Yeah.
There's a main transfer that we care about, and then there's always leakage. Okay.
Okay.
Energy leaks away. Unless the conversion is perfect, then okay, no 100% efficiency, no friction, no.
Yep. I shall continue working on this and also do my A2 since I'm not doing much A2.
Have you looked at the schedule?
Which schedule again, Miss?
Exam schedule.
Oh, wait, do I have
timetable? Do you know?
Yeah, I think I had it. I download and keep my mother downloaded and kept it somewhere.
Okay, so we are time zone 5, you know that, right?
Yeah.
Okay, so June to time zone 5. I am gonna dump one here. You see this library and resources on the notice board?
Okay.
I'm gonna put the calendar here, okay? So strategy is needed because I think your paper 2 and 5 is happening on the same day. That's Cambridge, that's what Cambridge does. So whenever you like, oh, where's the timetable? You go Discord now, okay?
Okay.
I know you downloaded it, but do you know where it is? Okay, you know how to read or not? Go to the end.
Yeah. Then it's down there.
So let's do this now. Where is this? Okay. PM. Interesting.
Oh,
Which
it's
paper
down.
tree? Which paper trees are you taking? Look at your statement of entry. Do you have a statement of entry already? No.
Yeah, I do have my statement entry.
So which paper tree are you taking? Is it 3-3 or 3-4?
Oh, there's a difference. Okay.
Of course, there's a difference. It's a very big difference. It's a 21-day difference. Hello.
If I'm not. Oh goodness.
News is they're all PM papers.
Yeah.
Morning to panic.
Drop check. Okay. I got the drop.
Which one?
Uh,
3-4 or 3-3?
3-4.
Guessing 3-4 course you receive candidates, they normally put your name last.
Mm-hmm.
Okay, so we're doing 3-4.
Yeah.
That is not good, by the way. I mean, it's like, can get this out of the way early. But never mind now, okay. So right now, the problem is that the papers are like this.
Yeah.
That's why I don't recommend finish AS and do A2. So your very first paper happens on the 10th of May, which is A2.
Yeah.
We are less than 2 months away.
Mm-hmm. And
So,
then it's paper 2 and paper 5.
yeah, and we also need to practice paper 5. We haven't done any paper 5 yet.
Yeah.
Or paper 3.
Or paper 3. Yeah.
Yeah. So 19.
We have more time for paper 1.
You always have more time for paper 1. Students seem to like to do paper 1. I don't know why. Okay, so in this scenario, right, when your papers are at the same time, they will quarantine you. So please make sure you know which paper you are sitting first and when you'll be quarantined, and prepare hard copy of the notes.
Oh, I see. Cannot bring devices in.
Cannot.
Okay.
And the quarantine is normally only 1 hour in between the paper. So you finish the paper with everyone. Let's say they let you do physics 2 first. So normally it's 1 p.m. to 2:15 p.m. So I think they will start the next paper at 3:30. Yeah. But between 2:15 to 3:30, you are sitting in the room and you don't have access to your device. So you will go from exam hall to quarantine room, from quarantine room back to exam hall. You can only bring your stationery and you can bring your bags, but you cannot bring your devices. So have your notes in hard copy, especially for these 2 papers.
Okay.
You see, you may think this is a big day because this is 100 marks. But this one is 60 and this is 30. This is also a big day because it's 90 marks, okay?
Yeah.
So this week is crunch week for you. I don't know what your German situation is. You may need to lay off it for a while if you really want it. The do or die KPI. 1 week, but this whole week is crucial. So somewhere closer to here, we can focus on paper 4 if we are sufficiently confident that we won't die in paper 2. Does that make sense?
Yep.
A bit like if I fireproof my house properly and then the front gate is on fire, I can focus on the front gate. I'm not scared that the back door starts exploding. I didn't fireproof my house in 2 months ahead of time then. Okay, anyway, 10, 19, and then 26, which is 5 days later. This one, here onwards, you can chill already.
Yeah.
Can be a bit more chill. This is 30. You go mark down on your calendar. You can set a countdown timer if you need a bit of panic. But if it causes too much anxiety, then don't do it. But I don't know. So here is 190. Here is 70. Almost 3 times.
Oh goodness.
Okay.
What is the minimum that I must get again, miss, to get an A?
Do you know your previous grades? You know, right?
My grades or the full, like,
Your marks.
the raw marks.
Mm.
If I'm not mistaken, you sent it to me once, or you told me about it once.
Mm-hmm. So it's loading. So I don't care because you're sitting 5 papers, so I'm going to take this. But this was abnormally low because the paper was abnormally hard. We expect
Okay.
this to go up a bit.
Okay.
So safer will be 165.
One
Because you
six.
also don't know which variant you're sitting, right?
Okay.
So safer is to aim for 165 or 170.
Okay.
I will aim for 170 just to be safe.
One
Later,
seven.
1 mark different, still B1.
Yeah.
So you see, if I get 158, if I sit this variant, I'll get A. If I sit this variant, I'll get A. If I sit this variant, I'll get B.
Yeah, that's true.
Only because I don't remember Hooke's law. Hooke's law was 2 marks or 1 mark. Is it? Yeah, you get the idea, right? 170 lah. So like that law, I don't know lah. So your marks, right?
It's really bad.
Yeah, but it's sort of like how you prepare. So everything you do has weightage.
Mm-hmm.
So it's important to, because currently your loading progress, this one is 2 out of 13 chapters.
Yeah.
And this loading progress, and I guess to a certain extent, this one now is
5 out of 10.
11.
Or 11.
Load more.
Okay.
So I think a safe bet for this one is for you to aim for 50 marks. This one we can go higher because it's easier. 55 is better lah, but you start with 50 first lah. So all can arrange later on.
Okay.
So this one out of 30, if you don't mess up too much, you should be able to get 25, 22, I have to get 22 lah. 不要 calculator, enough or not?
22 and then 28. 167.
Okay lah, something like that lah.
Okay.
Can?
Yeah.
Sure, this one, 45 can be 40 as long as somewhere else you mix up the marks lah.
Okay.
Okay, I'm going to screenshot this and pin it inside our Discord.
Sure.
So you may panic. You need a dose of panic just go and stare at it. Exam.
Yep.
Calm down. Work faster. But also stay awake. As in, like, be aware of your thinking. What I really appreciate is when you show up, you can explain clearly what's going on in your brain. So helping you learn. Just wish that you have more time.
Yeah.
Okay, so roughly something like this lah. So if you want to find it,
just go to the side and click pin messages.
Smart there.
Yeah.
Yep. Yeah lah. So if you want to, you can just, like, once you finish. So maybe your goal here is to finish what you can, so that you can actually touch a paper full on its entirety, do a trial run, and see where you are at.
Okay.
Does that make sense?
Yeah.
So until we finish a chapter, we wouldn't know.
Yep.
Okay.
Okay.
So level up the numbers. All right. So do you want to see me on Wednesday?
This Wednesday? Sure. Maybe we can do 1 hour.
Okay. So I will change this one.
But I'll let you know, means, like, it's also based on, like, how much I've done and whether I have anything to ask also lah. I also don't want to, like I said, I feel bad if, like, if we how to say, if I have class but then I don't do anything. Or if I have class but I didn't do anything before the class. Like today I felt good because like it's more than what? What time we started? Even about
2 hours. We are here for 2 hours.
yeah.
Mm.
It's been about 2 hours and we're still talking, not like last time every Friday, like halfway there and I'm like already blank. Don't know what to do.
Would it be better if we meet on Saturday for 1 hour also?
Sure, no problem.
Because Friday, you at least you have Friday and maybe Saturday morning to pause
so
and
that
adjust.
we
Would
can
that
do
work better for you?
online,
I mean, if you are okay with online, do you think you are learning worse that you're not sitting in MCQL with me now?
No, not that.
Yeah.
Maybe I feel like can I don't mind actually.
I think my
Saturday.
vibe translate quite strongly online also, right?
Yeah.
That's what my students say. Means your vibe the same in person. You same person ma. You think I want influencer with filter man, butterfly on my hair. But yeah, so if it's online, then we are much more flexible. Right.
Maybe we said Friday just in case. Then if cannot, then we put a Saturday.
Yeah, but my Saturday is always back to back one. My next class is 8 o'clock.
Jesus.
So I need to go and eat now.
Yeah, better.
Yeah, because we need to.
So that means, Miss, I would just like to ask.
Yep.
Is it okay if I put aside Dynamics 2, chapter 4? And
do you feel confident? Don't wait for me to affirm you. Affirm yourself. I did the work. I understand the thing. I'm ready to move on. That is what you should tell yourself if you think it's true.
yeah, I mean, yeah, I don't really need to focus much more on it now. Compared to like last time, I really had to work on it more.
Okay.
Now
So if you are sufficiently confident, then move on.
Okay.
Yeah. Now here the title is linkage, not me.
Yep.
Does that make sense?
Yep.
Got it. So a lot of time understanding is also what you feel in your mind and how confident you are. So it's not something that I know because I'm not you.
Yeah.
But it's something that I can help you be aware of. Like for example, if I see a question, do I know what to do? Etc. etc.
Okay.
Okay.
Yeah.
So I think to help you better, I just adjust all this whenever there is class.
Can no problem.
Does that make sense?
Yeah.
Online easier to track now.
Mm-hmm.
Okay. Anyway, if you need anything throughout the week, you can talk to me here as usual.
Yeah.
If can, maybe finish up the thermal physics.
Okay.
The 3 chapters, they're quite short and they are like repeating chemistry.
Yeah.
If you want a shortcut, there are speed run videos, which to be honest, it's 2 hours and 15 minutes.
Okay.
Okay.
Yeah, sure. I'll give it a go.
Yeah, you can give it a go. You can even pause here and just look at the map first before I even start. Yeah, then I'll walk you through the map, and then everything is here.
Okay.
Yeah. Okay, that's all.
Yeah.
So, yeah, see how it works for you. Because I think this chapter you have background in chemistry, should be fine. All right, take care.
That means now I need to do more A2.
I would prefer if you
balance it up.
Yeah, it's not. It's sometimes it's like now I need to love my son more than my first son more than my second son. No, not like that. Try to balance. Okay.
Okay.
You got 2 sons for a reason. You want to see 5 papers together.
Yeah.
You make the decision to see 5 papers together.
Okay.
So I have to take care of them because it's not like there is A2 and AS. You get the point, right? The 60 marks here and 100. And it's way easier to get the 45 than this one. Yeah. You know why or not? Let me show you the grade threshold before I go. The grade threshold for A for this paper is, for A, is 54, 55, 54. See this?
Yeah.
The paper was so hard that you only need to score half and 5 marks to get an A.
Okay.
It's a hard paper. A2 is hard, but you cannot totally zero.
Okay. Okay.
Okay,
Yep.
can
Got you.
do that?
I'll get the work done, miss.
All right. All right. Take care then.
Okay, miss. Thank you so much.
Welcome. Bye-bye.
Bye bye.
You're doing well, by the way. Just up the pace.
Okay. Thank you so
Bye.
much, miss.